Assalamu alaikum. Welcome everyone to another session on ETAP software. Actually, we are preparing a series of videos on the protection of power system and its components using ETAP software. So this will be the last one in that series, and we're going to show you how to protect a particular transmission line in the power system, because before in the previous experiments, we actually covered the protection of the generator. We covered protection of the load, and inside load we had motor also. Then we talked about the protection of the transformer. Okay. Then with protection of the bus bar. So all of them we covered in the previous videos or previous exercises. So the thing which is left in the power system is the transmission line. So which are going to do today. And if you look carefully, or if you think about it, that the protection of the transmission line is a bit different than the protection of the other components, because the generator, motor or load, transmission line, bus bar, they are kind of elements which are situated in a particular place. Even though they are big in size, but they are within a particular zone. So that's why you can apply the traditional way of protection, which is you can apply a CT, then a relay, then a circuit breaker to trip, isn't it? So this was kind of similar to each other, protection of generator, load, transmission line, and bus bar. But think about a transmission line. So if you're thinking about a transmission line, so this one is not same. This one is of course different than the other components. Why? Because the transmission line consists of this is actually a line which is situated or which is expanded through a long range of area. For example, if you have a transmission line of 80 kilometer, okay, think about it. You have a bus here, for example, this is bus 1 and this is your bus 2. So in between you have 80 kilometer length. So from common sense or from general understanding point of view, that you cannot put just one circuit breaker here and another circuit breaker here and you can cover the whole 80 kilometer efficiently, isn't it? Because it will create lots of problems and chaos. So that's why the protection of the transmission line is little different than the protection of the other components. Okay, so I will show you what is that and how it works. Actually, I'm trying to change the color, but I don't know why it's not working. The color is still the blue. Okay, however, no problem. So just have a look. The protection of the transmission line, the name of the protection scheme is actually impedance protection. Okay, impedance protection, okay, or distance protection. So, okay, so from the name, you can understand that in this protection scheme, we actually focus on the impedance of the transmission line, which is Z. And Z is something which is linked with voltage and current, isn't it? So this voltage is actually provided by the PT in the power system, and this current is provided by the CT of the protection mechanism. Okay, so the PT provides voltage, CT provides current. So if we try to draw, for example, the PT is supposed to be connected in parallel, right? So this is your PT, and for example, this is your CT. So this CT and PT both are connected with the relay. The distance or impedance relay, the code is 21. So this is code number 21 relay. So you need to connect them in a proper way. Okay, so maybe this is here, and however, okay, the connection. So this relay is actually getting the information of voltage and current from PT and CT, and taking the ratio between the voltage and current, it calculates the Z, which is impedance, And from the Z, value of Z, it understands whether there is a presence of fault or not. So if there is a presence of fault, of course, there are circuit breakers. It will take the action to trip. Okay, so these are the circuit breaker. Maybe you have more circuit breaker in the transmission line, maybe here, maybe here. Okay, so this is actually the mechanism. Now, what is the relation between the impedance and the distance? So the relation is very clear that we know already from our previous courses that there is a direct relationship between the distance d and resistivity. If your resistivity increases, if your distance increases, resistivity also increases, and vice versa. Okay, so this resistivity is also, you can replace that by Z. Okay, so from this idea, we can also get an information that the impedance is linked with the distance from a particular bus. So we will make a bus as our reference bus, and based on the value of Z, this relay understands or decides at what point exactly the fault happened. For example, if the total transmission line is 80 km, so this distance relay or the impedance relay will be able to give you the exact information that yes, at 50% of the line, the fault has occurred. Okay, so that means the fault has occurred at 40 km distance from this point, from this origin. Okay, so this is how the distance relay and the impedance relay works. And actually, if I draw a bit more over here to give you a better understanding. So actually, if you draw the plot of voltage and current, so this is actually, this curve is actually your impedance according to the Ohm's law. Okay, V by I. So this region is actually negative torque region, and this region is your positive torque region. In the positive torque region, your impedance, so that means the impedance of the fault is lower than the impedance of the setting. That means, you know, you set a particular impedance, for example, Z setting, like pickup setting, is equals to magnitude and angle, something, okay, r theta. So if your impedance provided by CT and PT is somewhere here or here or here, it means that this impedance is lower than the setting impedance, which means that there is a presence of fault. So it will generate a tripping signal. Okay, it will generate a tripping signal. Why? Because whenever there is a fault, occurrence of fault, it will cause the impedance to drop down. Okay, the impedance will drop down by a big number. Okay, so that means whenever it will go below the level of Z setting, it will generate the tripping signal. At the same way, this is the negative torque region where your fault impedance is higher than the Z setting. So it means that this is actually the normal zone of operation, negative torque region. So the delay will not generate any torque, and you know there will be no tripping. Okay, no tripping at this region. So this is actually the theory behind our work today, the protection of the transmission line. So I have gave you a quick idea, but I tried to make it a complete one, you know, a quick idea about what is actually the transmission line protection, how this is different than the other type of protection mechanisms, and why what is the actual protection mechanism's name. This is the impedance relay or impedance protection or distance relay. And we have showed you that the relation between the impedance and the distance are directly proportional, and how we apply that in the power system. So in order to apply that in the power system, we need to use a combination of CT and PT, both. And thus both of them will be connected with the relay, and the relay will take necessary information. So from here you can get the idea that the relay number 21, actually needs the information. It needs the information from CT, it needs the information from PT, and also it needs all the detailed information of your transmission line impedance. isn't it? Because if you don't provide the value of the transmission line impedance from before, it will not be able to uh, take any decision properly. Okay, so I hope it is clear to all of you. Let me proceed. Sorry, I want to. Okay, so I hope it is clear to all of you. Let me now go back to the ETAP software. Okay, now I will apply the same mechanism in the ETAP software. Okay, so in ETAP, where it is over here, actually I applied the protection mechanism, but I will show you in detail, of course, that how this works and everything. Okay, so this is actually the part where we will apply the protection mechanism. So you can see the bus bar number 3 and 5. In between we have a transmission line. This is the transmission line. Okay, and there are two circuit breakers, 10 and 11. So they will be used for tripping purpose. This is the relay number 9, but this relay is actually 19. Sorry, this relay is actually taken from here, relay number 21, distance relay. Okay, so if you just click and put it somewhere, you will see that this is 21. This is the same relay over here. Whenever I connect it, this becomes R. Okay, no issue. And this one is the CT connected in series. Okay, with the transmission line. This is your PT connected in parallel with the bus bar, and so here is the CT, here is the PT. Now let me first, so the connection is very simple. You just connect a CT PT and connect with the relay. Okay, now let me show you the setting. Okay, so you need to understand that you have to do the setting for CT first, then PT, and then the relay. Okay, the CT over here supposed to have the current which is coming from this T3 and T1, isn't it? Because you see both the branches are coming connected with the bus 3, and then it is going through the CT. So let me first show you that what is the current rating for T3 transformer 3. It is 132 full load ampere. So 132 ampere. This one is same 132 ampere. So together they will be around 260 or 270 ampere. So that's why I have put the rating as 400 ampere, a bit higher. You can make it 300, no problem. It will still work. Okay, just I kept some safety margin, 400 ampere. So this is the rating of the CT. Rating of the PT, the primary will be the rating of the bus, which is 140, and the secondary will be the rating of the relay, which is 120 volts, not kV. Okay, so the rating of the PT primary is 140 kV. You can see this kilovolts, and the secondary is 120 volts because the relay is designed to operate in 120 volts. So I hope it is clear. Now let's enter into the relay, and let me show you how I have done the setting. So the first one is just info. You don't need to do anything. Input. Okay, so input, there are multiple inputs. You see under the input you have current, voltage, digital, base. Okay, so under current I have selected CT23 over here because this is the CT which is providing current. Voltage, PT is PT1. So once you select PT, it will give you the primary, secondary voltage automatically. Then under digital, you have to, this is actually digital, you have to add high voltage circuit breaker and also the circuit breakers which you want to trip. So here you want to trip circuit breaker 10 and 11. So I have added 10 and 11. And as base, you have to select what is the base bus. So that means from which bus it will start the calculation. Of course, this is bus number 3 for us. You see, this is bus 3. Okay, I hope it is clear. Output, one of the output should be logic output because, I will show you at last that we will select one logic parameter. So that's why one of the output should be logic, and another output, it can be anything. And also under the logic output, DOI, this logic output, you add 2 circuit breakers which it needs to be tripped. So these circuit breakers in the previous exercises or examples were tripped directly, okay, by the relay. But here it will trip directly, but you can design some logic circuits or some logic elements in order to trip the circuit breaker more smartly. Okay, I will show you that whenever we'll proceed further to that step. So this is actually the output. OCR, overcurrent relay. So are we using any overcurrent relay in this exercise? Answer is no, because the overcurrent relays were used before for protection of generator, transformer, and for everything, because it was actually detecting the current, and based on the current value, it was taking decision. But for today's work, we know that this is not linked with current only. This is impedance, which is linked with voltage and current both. So that's why there is no presence of overcurrent relay. I deactivated both. This is overload relay. I also deactivated. Now, this is actually the point where you need to do some work. This is the distance relay selection. You see, distance start Z. So here you can see there are lots of values, okay, in this long list, and believe me, I have put them all manually, one by one. I had to. Okay, so you need to understand how I have done that. And also, I have selected one particular relay. You see, this is from Schneider Electric. So you can just go to library, okay, and you select one relay and manufacturer and model. Make sure this model has distance protection. Okay, so I have done that one. This is the model. Now, how I have put all these numbers and what is the meaning of them? So now let's focus on that point. Okay, so the issue is that you have to prepare one Excel sheet before you start inserting this data. Okay, otherwise, you will be facing difficulty in knowing what are the data you need. Okay, so this Excel sheet I have prepared and took all the data from our power system. Then once I prepared this Excel sheet, then just inserting this data over here. So what are the information present here? Just have a look. I have put here CT ratio, PT ratio from the CT and PT, impedance ratio, the ratio between them, line length. So the length of the transmission line for us is 100 kilometer actually. Okay, so maybe for your case it can be different, but for my one it is 100 kilometer. Then this is the impedance per kilometer, okay, of the transmission line. So you need to know that value. Where is that value? Where is that value? If you enter into the transmission line, if you enter into the transmission line, you will see that the length is 100 kilometer, as I mentioned you before. And then you go to impedance, look at the values. These are the impedances per phase and per kilometer. Okay, sorry, this is per mile selected. So if I selected per kilometer, they will be little different. Okay, yeah, they are little different. Okay, so actually I made a bit mistake over here. I supposed to select here kilometer, because the info over here it is selected kilometer. So the value, every value you should take here per kilometer. Okay, so I supposed to take these values. So however, actually I have already prepared the Excel sheet, so I will just show you. Consider these values as per kilometer. Okay, but when you do the experiment, make sure that this is supposed to be selected as per kilometer. Okay, so you just need to take this data. So just have a look. What are the data? This is positive sequence, negative sequence, and zero sequence. Resistance, reactance, admittance. Why? So admittance you don't need here. So you need actually impedance, which is the combination of R and X. Okay, so you just look at the number 0.104 and 0.74. So what I have done, I have put these numbers over here. Okay, so this is my R1 and X1, R2, X2, negative sequence, R0, X0, zero sequence. Okay, so when I put all this information over here, this yellow portion, I have to convert that into polar form. So I think all of you know it already, that like you can convert any Cartesian format, A plus IB or JB, you can convert that into R theta. Okay, so we call this Cartesian and we call this polar. Magnitude and angle, isn't it? So what I have done, I have converted all the information into polar format over here in the Excel sheet. So this blue highlighted part. Okay, well, then these informations were impedance per kilometer. Then you have to find out the total impedance. Do you know what is total impedance? So it will be for 100 kilometer. So just you need to multiply with 100. Just look this number. If you multiply with 100, you get 10.45. This number for the zero sequence resistance 0.377. If you multiply with 100, you get 37.7. So in this way, you find out the total impedance of the line, not only in Cartesian form, but also in the polar form. Okay. So this is the first task you need to do. Okay. Then proceed further. KD. KD is a constant. We call it zero sequence compensation factor. Okay. If you want to convert your zero sequence value from zero sequence to positive sequence, you need to use this compensation factor KD. And this KD is one of the data you have to provide inside this relay. Okay, inside this relay. If you look carefully, the third data, it is written here KZ1. Okay, this is actually KD. You see, compensation factor. It is written here, the formula. Okay, compensation. Can you see here, compensation? And what is the formula? Z0 minus Z1. So zero sequence impedance minus positive sequence impedance divided by 3 positive sequence impedance. Okay, so I put that formula over here and I took the data from there. So once I put the data, I got the magnitude and angle like this. Okay, now I understand that these values are not 100% correct because I have taken it in kilometer, but my data I have taken extracted from the ETAP are from on miles. So they are a little different. Okay, so but still based on the value of the kilometer, I have taken all this data and the protection mechanism works perfectly fine. So that's why I will not change now. Okay, maybe if needed, I will change it later. So but for like try to focus on the understanding how I have done that, that will be enough for you. Okay, so this is actually the compensation factor KD. After that, just have a look here. I have put some information. This Z1 is actually the positive sequence impedance, real value. X1 positive sequence reactance, R1 positive sequence resistance. This one is zero sequence. This Z is zero sequence resistance. Okay, so these informations I have taken from here. You see this blue highlight, blue highlight, blue highlight, blue highlight. So these 4 data are taken over here. Okay, now why I have extracted this data? And if you look at the title, what I have written, this is forward zone. Okay, this is zone 1 60%, zone 2 100%, zone 3 120%. What does it mean? Why I need to provide 3 zones and I need to put some percentage, and what is the meaning of that? Okay, let me explain that to you. I hope it is clear up to now. So what I was trying to say before is that here, for example, this is your transmission line. Okay, this is your transmission line, and this transmission line you want to protect using one relay number 21. Okay, now should this relay 21, this CT and PT, they are linked with this. Okay, should this relay 21 provide protection for the whole transmission line? What do you think? For example, your transmission line, our transmission line is 100 kilometer. So if I design this relay number 21 for the protection of this whole 100 kilometer, what do you think? Will it work perfectly? Will it work perfectly? Answer is no. One reason is that it is very long in length, and it will not be very efficient. But the main reason is that why it will not be efficient, because the length of the transmission line, for example 100 kilometer, and the associated Z of that is not fixed. It may vary. Why it may vary? Because the transmission line length and the impedance varies under different situation of weather and circumstances. For example, we know already, like if in the summer, okay, in summer, when the temperature is high, the length of the transmission line increases, isn't it? If the length increases, this will not become 100%, 100 kilometer. Maybe this will become 104 kilometer. Who knows? So if you provide all the information for 100 kilometer, and in summer it becomes 104 kilometer, all the data will be needed to shuffle, and you have to check every day, and you have, in order to ensure the accuracy, isn't it? So that means, as because the length of the transmission line 100 kilometer is not 100% fixed and it varies with time, so you cannot provide only a single zone of protection. Remember, we covered the protection zone in one of the previous chapters. So, and we know that the zones are very important. Okay, so if you just provide only one zone, that will not be enough. Okay, so what you have to do, actually you have to provide multiple zones. So here what we have done, actually we have provided 3 zones. Actually, one is for 60%, another for 100%, another for 120%. So that means if in summer this has been increased a little bit more, no problem, it will cover by this 120% protection mechanism. Okay, so if you want to if you can provide some more zones, it is much better. Okay, so but here at least we have provided 3 zones. So 60% zone is, for example, up to here. Okay, so this is actually the first zone. This blue one is zone 1. Okay, this is our zone 2, and the last one, for example, this is the zone 3. Okay, so this is the zone number 3. Okay, so these 3 zones, if you provide, then based on the value of impedance, it will take the decision in which zone it falls. For example, we'll talk about these impedance relay characteristics more in the lecture class, but just to remind you that this was the torque region. Remember, this was the positive torque region. So for example, up to here is your zone 1. Okay, up to here is your zone 2. So here is their zone 3. So if any fault occurs in this position, okay, so it will be tripped by the relay, by the mechanism of zone 1. Okay, and if it is here in this zone, this is your zone 2, and if it is here, okay, if it is here, then it will be your zone number 3. Okay, and so on. So I hope it is clear. That's why you need to divide your data in these 3 zones. You see, this zone 1, zone 2, and zone 3. Now you need to put all this information over here. Okay, just let me show you how. So the first one is line angle, and line angle is this 80 line angle, this 82, where I have taken this from. You see, this 82 is the impedance angle. Okay, after that, this zone status, which zone is enabled and disabled and so on. This is actually I got it by default, so I didn't change this one, but you can change that one by following this description. Okay, if you want to enable or disable any zone, you can just do that by putting 1 or 0. 1 is to enable, 0 is to disable. So this is by default in this format, so I haven't changed it. So this is compensation factor. Let me bring this one. Okay, so just have a look. This is compensation factor magnitude, sorry, just leaving magnitude and angle. So over here, KD 0.83 magnitude and angle. Okay, then this Z1, Z1Z, Z1X, R1G, and R1 phase. These 4 values are actually these 4 values for 60% first zone. So here 1 means zone 1. Okay, so I have provided this information here. Then the next true data, TZ1, and TZ1 is actually the time delay for zone 1. So I have provided there is no time delay, so that means 0 second. So then again, the compensation factor, same as before, 0.83, and this one. Okay, then this one for zone 2, Z2, R2, and R2 phase. Okay, so we have provided the information for zone 2 here. This is the time dial or time delay for zone 2. This is the compensation factor again. This is zone 3, and this is the time delay. And zone 4, actually I haven't provided any zone 4, so we can make it 0. Okay, there is nothing in zone 4. Okay, so you can provide 4, 5, 6 zones, whatever you want. Okay, so this is actually the way you have to provide the information. I hope it is clear. Then the last one is this schematic logic. Okay, in this schematic, under this schematic logic, you have to provide some logic information, but we'll make it simple. If you look here, actually there are a scope that you can use your AND gate, OR gate, NOT, and XOR gate to provide different type of protection logic and so on, but we'll not make that so complicated here. What we have done over here, you just have a look. Under this, there are some tabs: protection element, input, timer. You can select some timer. You can add, and there is latch, control variable. You can put some control variable, output. Okay, so once you reach in the output, you have to add one output. Okay, so if you click add, once I click this add, this DO1 has been inserted. Okay, so just have a look. Can you remember where I have taken this DO1? Where? So this DO1 is the output which I have taken over here in the output tab. Can you see DO1? So this DO1 is the relay element is logic. So this is controlled by the logic. Okay, so you have to link this DO1 with this logic, and you have to assign that logic over here also, DO1. And once you select this DO1, and this logic expression supposed to be this one. This is distance trip. So this will be tripped by the distance relay. So will not directly distance trip. Okay, so it will not apply any logic circuit or anything. It will trip based on the information of the distance relay. So under this distance trip, this DO1 is working. Under this DO1, this you can see under this DO1, these two circuit breakers are working, circuit breaker 10 and 11. So which is already been added. So once I will apply any fault over there, so it will generate the tripping signal for circuit breaker 10 and 11. So this is actually the whole mechanism of giving the setting for a particular distance or impedance relay. So let me close this one now. I hope it is clear for the viewers. Now I will show you how to apply the fault and see the protection scheme. So the previous 2-3 example exercises or videos, we actually use this tab, protection coordination star, but today we are going to use this one, start Z for impedance. So once you click that one, okay, so you just go to edit study case, you will see that you can apply different type of fault. Okay, let us first apply a single fault. Okay, we'll apply a single fault, 3-phase, and the reference bus is bus 3, and you can select that one. And at what location you want to apply the fault, you can apply the fault in 0% of the 0% distance from bus 3, which is on bus 3, 50%, 70%, 90%. So you can decide yourself. Let us select 50%. Total simulation time is given. Pre-fault loading not needed. Protective devices are already selected. What are the protective devices selected in this particular power system? You can see we have relay number 5, which is protecting generator, relay 9 protecting generator 1, relay 10 and 14 protecting lump load 1 and 3, and now we have applied relay number 19, which is protecting our transmission line 1, and the manufacturer, everything. So they are all listed over here. Okay, so and also here you can identify how many circuit breakers you want to trip. I think not here, in the sequence viewer most probably. Okay, so well, it is fine now. Now we are going to apply a fault. Okay, so this run start Z study. So once I click that one, You see, circuit breaker 1 is tripping, 2 is tripping. So this is the primary relay, okay, and these 3 and 4 are the backup relay. As because we have selected 4, this is the sequence viewer. If you just click on the sequence viewer, you will see that the relay operation time is over here. So circuit breaker 10 is tripping first over here. Just have a look. Circuit breaker 10, which is here, this is tripping first at 50 millisecond. 11 is 100 millisecond. Then 6 and 8 are backup, 103 and 103. If this 50 and 10 and 11 are not operating, okay, you can see a difference of time between 10 and 11. Why? Because this will try to isolate from this end, the end which is closer to bus number 3. So that means this circuit breaker, which is circuit breaker 1, should trip first, and then if it fails for some reason, circuit breaker number 2, which is this circuit breaker 11, it will trip at 100 millisecond, okay, and this 3 and 4 will be your remote backup. So this is how actually it works. If I just go to the case study, actually it is applying a fault which is known as sliding fault. Can you see this sliding fault? Okay, now if we apply a single fault, if we apply a single fault, once again, you will see the same. What is the difference between single fault and sliding fault? I just want to show you. This is actually a single fault. You applied a single fault and you see the tripping mechanism, same like I have explained before. Now, if you want to apply a sliding fault, this sliding fault, can you see this third one, sliding fault? If you want to apply a sliding fault, what does it mean? It means that actually you can slide through your transmission line and see the fault at different location. Okay, so just I select this sliding fault and click OK. Now I apply the fault. Just have a look. Once I run the fault, the tripping are same. Look, the numbers, tripping are same. Okay, but what is new here? If you go to the sequence viewer, see something very interesting over here is that you have a sliding option in your hand. Can you see? This is location. Now this is 0% from bus 3. So here now the fault is applied from 0% of the bus 3. That means over here on bus 3. But now you can change this one. You see, now I have clicked. It has become 10% from bus 3. You can make it 30% from bus 3. 40% from bus 3. Okay? Because the setting has been made for a step 10%. So it can be changed up to step 1%, 2%, and so on. So now the step is selected 10%. So once you click every time, it will be increased by 10%. So now this is 50% from bus 3. So 60, 70% of bus. So it means that now if we apply a fault on 70% from bus 3, it will be falling in the second zone of your protection mechanism, isn't it? Because the first zone was up to 60%. So this is how actually you can slide through the line and apply the fault at different locations. Okay, and maybe you have noticed that one. Just have a look. That once you click the percentage, the value of the current. You see, these are the values of the current, magnitude, angle. They are in all different values you are seeing over here. So they will change. Just have a look. If I put it here, can you see all the values has been changed? So if I put here, all the impedance values has been changed. So that means, the tripping position will be same, but the value of the impedance and all the detail will be changed based on the location of the fault. I hope it is clear to all the viewers. And actually, this is what I had to explain in this video. So a very quick summary is that in this experiment or in this video, we try to show you the way of protection mechanism for the transmission line. The name of the protection mechanism is impedance of the distance relay, where we take the information for PT and CT, convert it into Z. This Z is linked with the impedance, and by the value, with the value of impedance, it takes the decision whether it should trip or not trip. So this figure shows the detail that when it will fall in the positive torque region for tripping or negative torque region for not tripping. Okay, so and also we showed you that you cannot cover the whole power system with a single zone. It is not prescribed, because it will reduce the efficiency or the accuracy of the protection mechanism. So you have to provide multiple protection zones. So here we have provided 3 protection zones. And before you go for the ETAP simulation, you need to get the information from your transmission line and the impedance data and everything, and you have to prepare one Excel sheet. This will help you to do the calculation and prepare all the data which are needed for the ETAP software setup. So over here we have applied 3 protection zones. This is zone 1 and zone 2 and zone 3. Okay, and we inserted all this information in the relay over here, relay number 21, in this start Z distance, and thus it takes the decision of tripping the circuit breaker 10 and 11 based on the position of the fault. So thank you very much for listening. If you have any question, feel free to put your comment in the comment section. Thank you.